This is 6.2, Properties of Parallelograms. So before we get into properties of parallelograms, I realized I don't have the requirement for a parallelogram on this paper. So I'm going to start with that. To be a parallelogram, you must have, it's a quadrilateral. Quadrilateral with two sets of parallel lines. So that is what is required to say that a figure is a parallelogram. It has to have four sides, being a quadrilateral, and the opposite sides need to be parallel to each other. Okay, so then once you see you have a parallelogram, then there are four characteristics that we're going to look at that you know are true if it is a parallelogram. So if it's a parallelogram, then its opposite sides are congruent. So that means the left side is the same length as the right side. So I could say segment AB is congruent to segment DC. And I know the top is congruent to the bottom. So I could say the segment BC is congruent to segment AD. So that is the first thing, number one. Number two, the second thing we know about parallelograms, or we know about a figure if we know it is a parallelogram. If it's a parallelogram, then its opposite angles are also congruent. So in this case, we could say that angle A is congruent to angle C because they are across from each other. They are opposite. So angle A is congruent to angle C. And we also know that angle B is congruent to D. The third thing that we know about the figure, if it's a parallelogram, is that consecutive angles are supplementary. All right, so when we went over parallel lines and transversals a while back, I used the phrase same side supplementary, SSS. So this is the SSS. Same side. Another way of saying same side is consecutive. Consecutive means right in a row, directly the next one following. Same side are supplementary. So they add up to 180. So in the figure, angle A plus angle B is going to equal 180 degrees because they're on the same side of the figure. So they add up to 180. And the same for the top, B and C. You can add those together and it's going to equal 180. And the same thing goes for the right side, C and D. Angle C plus angle D equals 180. And the same thing goes for the bottom, angle A and angle D. They add together to equal 180. So if the two angles that are connected by the same side will add up to be 180, they are supplementary. And then the fourth characteristic of parallelograms that we're going over today has to do with its diagonals. If it's a parallelogram, then its diagonals bisect each other. So remember, to bisect each other means they are cut exactly in half. Not just that they intersect or anything like that. Just they cut in half, exactly in half. That's what bisect means. So looking at the picture, we know that this diagonal is cut in half. So I really need to name the middle piece. I'm going to call it M in the middle. So I know that B to M, so segment BM, is the same length as D to M. And then I know the same thing about the other diagonal. A to M is the same length as C to M. So one thing to be clear on, it does not mean that all the pieces of the diagonals are the same. Possibly they could be in a special situation. It's just saying if you have a diagonal where the other one crosses it, it cuts it in half. So these pieces are the same and these pieces are the same, but not necessarily all of them. If all of them were the same, that would actually be a rhombus, which is a parallelogram. It's that always, sometimes, never thing. But we do know each one is cut in half. Okay, so the first example, it tells us that we have a parallelogram. It says, given JKLM is a parallelogram, list all congruent and supplementary angles as well as congruent segments. So I'm going to set up a table with congruent angles and I'm going to list supplementary angles and I'm going to list congruent segments. Alright, so congruent angles, I know that opposite angles are congruent. So I could say that angle K is congruent to angle M because they are across from each other on the parallelogram. And then I also would like to say that J is congruent to L. But I can't just say that angle J is congruent to angle L, because if I say angle J, you don't know which part I'm talking about. I could be talking about the whole thing. I could be talking about this side of it, or I could be talking about this side of it. I don't know. So when an angle is split like this one is, I would have to call it angle KJM, or MJK. So, but I know that angle KJM is congruent to angle MLK. The one across from it. But that's not all that I know about congruent angles, because again, with parallel lines and transversals from that previous unit, if these are parallel lines and they are connected by this transversal here, it gives you that Z shape, and I have the little phrase, Z angles are Z same. So if you find the Z angles, like angle 4 and angle 3, they are alternate interior angles. They alternate the transversal and they're interior of the parallel lines. They're Z angles. And the way that I knew where to put my red line, it's touching both of the green lines. Like for 4, instead of 2, if I tried to mark 2, I would start on the green line, but there's no green line on this side. So that's not the right place to put it. I put it over here between the 2 green lines. So that's why I have angle 4 and 3 are alternate interior. And so they are congruent. So angle 4 is congruent to angle 3. But I could also I have another set of parallel lines. If I use the other set of parallel lines, then I get a different set of Z angles. So now I get angle 1 is congruent to angle 2. The other set is also congruent because of the other set of parallel lines. So angle 1 is also congruent to angle 2. Alright, so that covers the congruent angles. The next section says supplementary angles. So I want all of the angles that are supplementary. I'm just going to start with the top. I know I'm making that shape to add to 180 whenever I want supplementary. So I could say angle 5. And on the other side, I don't want to just say angle 4 because that's not the whole corner. I want 4 and 2. I want that whole corner of angle L. Everything that has to do with angle L, I have to include it all. So in this case, I would say angle 5 plus angle 4 plus angle 2 equal 180 degrees. And then I could do the same thing with L to M. That bracket shape is going to give me supplementary angles. So angle 4 plus angle 2 plus angle 6 equals 180. And then, of course, I could do that on the bottom with angle 6. And then for the corner where the J is, I have to use 1 and 3. I want the entire corner, both of those angles. So angle 1 plus angle 3 equals 180. And then the last one would be angle 5 plus angle 1 plus angle 3 equals 180. So you have supplementary angles on all 4 sides. And then the last section that I need to list is congruent segments. So for congruent segments, opposite sides are congruent. Since the diagonals are not marked, only one diagonal is marked, not both of them, I only need to worry about the left and the right sides. So I can say that angle K is congruent, no, not angle, I'm not talking about angles, sorry. Segment KJ is congruent to segment LM. And I also know that the top and the bottom are congruent. So segment KL is congruent to segment JM. Okay. So then the next part is asking, are the following quadrilaterals parallelograms? And if yes, state the reason. Alright, so number 1, I see that I have diagonals that are marked. So if I go back to my list of characteristics, that's characteristic number 4 says, if it is a parallelogram, then its diagonals bisect each other. So looking at this picture, does it look like the diagonals bisect each other? To look at that, we're going to just look at one of the diagonals. Has that diagonal been bisected? GE. The bottom section has 1 line and the top section has 2 lines. So, no, those are not the same length. And the same go in the other direction. Those are not the same length. So it's the right number of matching pieces, but they're not in the right positions. So because this one has 1 and this one has 2, that means those 2 pieces are not the same. So this is not a parallelogram. So no, it is not. And then on number 2, it says that parallelogram ABCD, where segment AB is congruent to segment CD, and AD is parallel to CB. Well, it didn't give me a picture. I like to sketch a picture. So I have A, B, C, D, and it tells me that AB is congruent to CD, and the AD is parallel to CB. So I have a set of parallel lines and I have two congruent segments. So is it a parallelogram? Yes, it is. Even though the requirement for a parallelogram that I wrote at the beginning said it is a quadrilateral with two sets of parallel sides. This figure I drew doesn't show two sets of parallel sides. But if I have one set of parallel sides and they're connected by segments that are the same length. All right, so if you have parallel lines, is there any way to connect them with segments that are the same length and not have a parallelogram? Let's see. So if I have this piece, so, this is my parallel, and that one is a set length. You know what, I could. This is not enough information, is it? Because if this one slanted the other direction, it could be the same length, right? Right, that's what I'm saying. So that looks more like a trapezoid. There's one set of parallel lines, and they're connected by lines of the same length. But if those lines of the same length are not on the same slope, that could be the inverse slope. So no, that's not. That's not enough information. All right, so then let's look at the last one. A, B, C, D, we have two opposite sides are congruent. Opposite sides are congruent, so we have two sets of lines that are the same length. Do we have enough information? Yeah, because we can see this one's a little bit based on what it looks like because that same length doesn't go in the same way. So yes, we do. Because the only way to connect these would be if they're parallel. Okay, so the number 4. Determine the values of the variable for which the following would be parallelograms. So we want number 4 to be a parallelogram. In order to make it a parallelogram, the opposite angles would have to be congruent, right? And I went to opposite angles because clearly the information is talking about angles. And if I look at my list of characteristics, there's opposite sides, that's not helpful. Opposite angles, yes. Consecutive angles, that's also helpful. I could possibly use that one. And then diagonals bisect each other. But the reason I can't use consecutive, or at least not right now, is because it would have to be those two angles. Well, it could be those two, or it could be these two. But the reason I can't start off dealing with consecutive angles is this one has an x in it and this one has a y in it. So it's not the same variable. So I can't solve for one. This one has an x and this one has a y. So before I can use this one with the y in it, I need to figure out what x is. So I can find out one of these two angles. So I'm going to start off by saying opposite angles are congruent. So 2x plus 20, actually hold on, I'm going to write that slightly different first. So angle Q is congruent to angle S. And if I want to solve, I can put what it gives me for angle Q, 2x plus 20, is equal to what it gives me for angle S, 3x minus 25. And now that I have an equation, I can solve it. So I'm going to subtract 2x. When you solve, you want to get x by itself. So I'm starting by getting all of the x's together. So I know I have 20 equals x minus 25. The next step to get x by itself is to add 25. So now I have 45 equals x. And this problem did ask me to find the variables, so I found one of them, x is 45. And now that I know what x is, I could plug it back into either one of those, it doesn't matter, and use the consecutive angles property to find the other one. So if x is 45, I come up here to 2, so I could take this and say 2 times 45 plus 20. And it's going to give me that angle, angle Q. 2 times 45 is 90. 90 plus 20 gives me 110. So I know that angle Q is 110 degrees. I also know that S is also 110 degrees because I know that they are the same. And if I want to add to 180, I could say that angle R plus angle Q equal 180. And I know that angle Q is 110. And I know that angle R is 5y. So now I filled in everything. 5y plus 110 equals 180. So I can solve for y by getting it by itself. Subtract 110. So 5y equals 70. And then you can divide by 5 to find out that y is 14. Because you will have some of these that have two variables, and you have to figure out which one to solve for first. The one that you have more than one of, that's the one you'll solve for first. Okay, so then number 5. On number 5, we have diagonals. So since we have diagonals, we look at the property about diagonals. That was number 4. If it's a parallelogram, then its diagonals bisect each other. So if I look at diagonal LN, I know that one side has to be the same as the other. And if I look at MP, I know that one side has to be the same as the other. And to see which one to start with, well, which one has the same letters in it? MP has X and X. LN has Y and X. So clearly I need to solve for X before I can go to the one with the Y in it. So I'm going to say that 4x minus 2 equals 2x. Because it's bisected. So when solving for x, you want to get all the x's to the same side by themselves. So I'm going to start, normally I start with subtracting the smaller one, but that's whenever I have two terms on both sides. Right now I only have one term on the right. So I'm going to go ahead and move my x's over there. It'll be less work in the end. So if I subtract 4x, then I get negative 2 equals negative 2x. And I want x by itself, so I divide by -2. -2 divided by -2 is 1, so x equals 1. All right, so if x equals 1, now that I know what x is, I can take it and put it into the other diagonal where the x is. So this is 5 times 1 minus 1. 5 times 1 is 5. 5 minus 1 is 4. So I know this whole side over here is 4. And now I have another equation, because I'm going to set those two pieces equal. So 2y equals 4. And that's pretty easy. Just divide by 2. So y equals 2. So when there's more than one letter, you have to see which one you can solve for first, and then plug it in and solve for the other letter. All right, so the next section, is it a quadrilateral, and if so, explain. So to be a quadrilateral, we have opposite sides are congruent, and then I have the set of alternate interior angles. This one and this one. And since I see they're alternate interior, that means those are z angles. So this, if you make the z shape, you can see where the parallel lines are. So I know that the top and the bottom are also parallel lines. Okay, so I have parallel lines that are congruent. This is a little bit different than the other one that I said did not make a parallelogram, because I didn't know, because this was a pair of parallel lines and the others were the same length. But like I said, they could be going another direction. So if it's like this, then it's not a parallelogram. We didn't really know. But on this one, the set of parallel lines are the same lines that are marked congruent. So if lines are parallel and the same length, the only way to connect them would be with another set of parallel lines. So because the way this one's set up, I know that these lines are also parallel, and now I have my two sets of parallel lines that defines a parallelogram. So this is yes. And so once I've decided that I have a parallelogram, I can figure the rest of this out. So find BC. Where is BC? Here's B to C. All right, so if I want that side length, well, I see across from it is 11, so it must be 11. And then find XC. All right, so where's XC? From the middle to the bottom right corner. Well, that must be the same as the other part of that same diagonal, so it has to be 7. And then find DB. D to B is the entire length of the diagonal. This one's a little bit different. So I see from D to X is 8. So then from B to X is also 8. But this one's the entire thing, so it's 16. It's the whole diagonal. All right, so then the last little bit is the plotting the figures. All right, so we have, find the coordinates of the intersection of the diagonals. A is at 3, 6. B is at 5, 8. C is at 3, -2. and D is at 1, -4. All right. So this is the parallelogram. Whoa, that's terrible. All right, so once that is said, where's the intersection of the diagonals? So I need to draw the diagonals. That's going to be really, really hard for me to do. All right, I'm just going to get a ruler. All right. So you can draw the diagonals and then see where they cross. Right there, so these cross at the point 3, 2. Now, in another situation where this is, say, on your screen and you can't do this because it's on the homework website, you could, another way of figuring it out is see the highest point is right there at 8, and the lowest point is at -4. So from -4 to 8, that's at 12 units, right? So the middle of that is going to be at 6 units distance. The distance to the middle. So this distance is 12. So if I want to go halfway, halfway is at 6 units. And it gives me here at 3. So it gave me the 3. And the same for the horizontal. Farthest left point is right here at 1. The furthest right point is here at 5. So that's a distance of 4. So the middle of that is going to give me the point 2. So you can do it either way for that type of problem. And then the last one is a question. Every time I've taught geometry, it's been on the test. It's really a fairly simple question if you're aware of it beforehand. So I would put a star on it. It says find the coordinates of D for a parallelogram ABCD. The order that you read those letters in is very important, because you can plot the other 3, -4 and 3, and that's A. 2, 3 is B. C is at -1, -2, and you have to find D. So I know A goes to B. Because of the order of the letters, I'm going to go clockwise when I graph. So I know B has to connect to C because the order of the letters at the top is A, B, then C. So B connects to C. So D has to be over here somewhere. And since C is over 3 spaces from B, then D is going to be over 3 spaces from A to make it parallel. So I know it has to be right there. It's very common. People want to put it over here. But that cannot be point D because it has to match the order the letters were given. If you put it over there, that would be A, B, D, C. That would not be the same thing. All right, so that is parallelograms.